All right, is your parent rational?
No.
Yes, no, no, maybe. Okay.
Dave should be here throughout the middle of the class.
Okay. See in the library getting the schedule. All
What are
right.
you doing this for?
What is the word that's hidden inside here besides rat? Ratio, yes. Somebody said rat last time.
Ion.
Ion, there you go. How many words can you make? No, just kidding. All right, so
I was gonna say, I'll be like
why is
this.
it called a rational function? What's a ratio?
It is a ratio.
It's a ratio. Ratio is a fraction. Okay, so why is it rational? Because it is a fraction. And specifically, it's a fraction with x in the denominator. So, because it is a fraction with x in the denominator. For example, x over 2 is a fraction, but that's not rational because x is not in the denominator. It's got to be in the denominator. What do we mean by a parent function?
It's what the other ones are based on.
What the other rational functions are based off. Okay, that's good. Anybody else? Okay,
That's it.
we're going to put it is the most basic, simplest function. Right now we're going to put y 1 over x in y equals and find all the points on this table and then plot them. Hello class, what are you doing? Somebody was playing with my calculator.
Ha. This calculator is something that's not taking.
Well, they set the table so that you could find 0.5 and 0.25, probably.
Yeah, but they do a little bit different. Instead of going by 0.5, they went by
0.25. Maybe. I don't know.
Negative.
0.25. You get negative 0.1.
What's 0.2?
Yeah, negative 0.1 for negative 10. Yes.
That took forever to get to. Yeah.
Does everybody have their tables set where you can get the other, you know how to get the decimals? Thank you. Let's grab this on your table. Anybody need help with their table on my calculator?
Is
Is that a yay? Yeah.
You want us to graph it?
Yeah, go ahead and
For
plot.
negative-
Wait, you have your table done, you can plot.
for negative 0.5?
Make it 0.25.
And have it start.
They'll get it.
Negative
There you go.
0.5.
Have it started.
Wait.
Negative
0.5,
Yeah.
Negative 2.
Hey, David.
Attaboy, Dave.
Is your schedule done?
Yes.
You didn't miss much. We just started.
That's okay.
Okay, you can't do negative 10, negative 0.1, right, on the graph. You have to start with negative 5, negative 0.2. Bless you. What is an asymptote?
A lot of never touches an X.
It's the barrier.
Something like that. It's the barrier, okay? The boundary. It's a line that the graph does what? It never touches it, but it does keep getting closer and closer to it. So what we're going to say is, it is the line that the graph approaches but never touches.
Pardon the interruption. We need the following students with their laptops in the library. Alyssa Blunt, Maya Brumley, Zela Culpepper, George Hernandez, Stephen Hunter,
Maya.
Emmanuel Lucio, Danielle Patrick, Montgomery Ramsey, Dylan Brightman, Jacob Camp, Victoria Ertl, Rosemary Hernandez, Tara Jones,
Rosemary.
That's you,
Are
sister.
you sure?
Mayhem, Billy Payne, Cassandra Ross, Robert Croxton, Eric
It is.
Hernandez, Cameron Horton,
Stacy's
Zach
birthday.
Laredo, Cameron
I can't believe
Mosey,
she's 17.
It's on my
Elijah,
calendar. My phone.
Oh, really?
From
Yeah, it's a
Facebook.
tech- yeah, it's to my face.
please go to
It's from
the
Facebook.
library.
She's been informing me since like
That it's her
2
birthday?
Fridays ago that
That her birthday was coming?
Yeah.
Wow, okay.
And chemistry, so.
Well, I'm sure on this day in history, Coach Walton probably had that up there too.
I couldn't forget.
Okay, now where are the asymptotes in this parent
The X
fraction?
and the Y.
The x-axis and the y-axis? Good. The x-axis is the horizontal asymptote. Goes across here. We always use dotted lines for asymptotes because they are not part of the graph. So that dotted line tells you that it is a boundary, but not. It basically tells you where the graph does not go. Okay. What's the equation for the x-axis? Equation for that line.
Y equals 0.
Good.
Yeah.
And the equation for the y-axis?
X
X equals 0. Very good. Okay, then how does this affect the domain and range? In other words, the domain is which one? X or y? X. So what can X not be in this graph? 0. Okay. So that it can be anything except that. So we could say the domain is all reals except 0, or we can assume that we mean all reals and just put X is not equal to 0. Okay. It can be anything except 0. Another way to write this domain, oh, look at my line, it's kind of curvy. Oh well. Another way to write this is, it's going from to negative infinity to 0. Y'all haven't seen much like that, but it's like this. Negative infinity to 0, and then there's a break. Okay? And then it goes from 0 to, what would this be out here? Positive infinity. Infinity is this little sideways 8. Okay?
That's
See
what
it?
we draw.
Just turn the
Turn your paper over, draw an 8. Yeah. Can you do that? Okay, and then they'll put this little U in between. All that means union, which is just like a plus. It's saying this one plus this one. Okay. All right, then the range can be, y can be any number except what? 0. Okay. So y cannot equal 0. Or another way to write this one would be, same thing, from negative infinity to 0, and then there's a break, and then from 0 to infinity. Okay, when we use parentheses, that means 0 is not included. If you use a bracket, then 0 is included. In this case, it can't be 0, that's why we put parentheses here. We show 0 is not included. This is a new way to write that y'all haven't really seen much of, right? Okay, this is called interval notation. You've been doing set notation where you do x is less than 0 or x is greater than 0. You may see it either way on a EOC test. I like this way the best. It makes more sense that you go from here to here and then from here to here. But, Okay, now down here, they want you to draw in the asymptotes. Can you tell where the asymptote is on the first one?
Yes.
Where is the break in the graph?
2.
At 2. That's your vertical asymptote. Where is the break horizontally? At 0.
Yeah.
So for the domain, let's just use the short method on these. What can x not be?
0.
2.
2,
2.
right? X cannot be 2. That's where the asymptote is. Okay, and then for the range, y cannot equal 0. Okay, where's the asymptote on the next one, the vertical one?
-1.
And then where's the horizontal one? Okay, so domain, x cannot equal, and range, y cannot equal
2.
Good. Okay, the last one, 3 is the vertical asymptote, and -2 is your horizontal. So domain, x cannot equal,
3.
and range, y cannot equal -2. Okay. Now you're going to need your notes. It's got all out of whack there.
What about this?
We're going to do that after we do the notes. Like I said, it's kind of messed up, yeah.
So now it's this.
Yes, we're going to do the transformations of rational parent functions.
Yeah. That's in the water.
Okay. In order to do this, you've got to set your window to these settings, and some of you, your window may already be set. We've been doing this today. Just check your calculator and make sure your x min is -5.75 and x max is 6.
Wait a minute.
Right here, it's right there on your paper. And this is a puzzle. Whoops, I got the wrong one.
That's why I can't see it. What?
Yeah, here we go. What happened?
I've been going down, see if it ever went to 0.
Oh, did it?
No, I'm on 1770 and it's 5.6 times 10 to the -4.
It'll like be 10 to the
Yeah.
-30 and it'll just keep going. Very good though. Seeing that. Okay. What we're going to do is put in, well, let's do the one they did. Just see what they did. 2 divided by x. And then graph. And don't hit zoom or you'll change your window. And they said, look, you got to match it. And it looks like the one that says thanks. Okay. So that's why they wrote thanks down here. Then we're going to do -2 over x. What do you think the negative's going to do?
Flip it. Wait a minute.
You know,
It's
flip
gonna
it.
change quadrants.
Well, it flips it,
It's gonna still.
and when it does that, it changes quadrants because this flips to the bottom and that flips to the top. Okay. So does this match any of these? No. So you got to turn it sideways.
Now it does.
Now, which one does it match though?
2.
Okay, why 2 and not what?
Because that one is
What is like skinnier?
Yes.
Further down.
Yes. Okay. The 2 matches better.
Yeah, that's legit.
All right, so we're going to put 2. Then how do you plug in 1 over x minus 2?
One
is
divided by
important.
parentheses x minus 2.
Yes, if you don't put the parentheses, then it will not graph it correctly. You have to have parentheses. When you have more than one thing in the numerator or denominator, you need to have parentheses around the numerator or denominator.
Times 2.
What happened to this one? It moved which direction? Moved right. How many?
2.
2. What do y'all think?
Television.
Television? Okay. Okay, and then you're going to keep going that way. Now, I want to make sure you know how to put in this 1 over x plus 4.
Did you put the 1 on it?
1 over x in parentheses and then
on the outside.
Yes, you want, right, parentheses, 1 divided by x, close your parentheses, whoops, yeah, that's right, plus 4. What happened to that one?
It's just, so we remember.
It went up how many? 4?
4.
Yes, it will be remembered. Okay, y'all go ahead and finish these out and don't say the words as you do it. Let everybody
Where was that?
figure it out on there. It's this 1 over x plus 4.
How do you go do the things?
Which one?
And the 1 divided by x plus 2. I think I got it, but I don't know.
Yeah, this one's big.
I can't do that.
This is pretty good.
Yeah. Okay, maybe you can do
Yeah.
No, yeah.
It'll just be
You don't need parentheses, you just need it around the x plus 2.
if that makes sense.
Oh, I got the volumes of the profile or something. And he got mad and he goes, he just looks at me and my hand's on the desk and he's like, I'm gonna punch my hand. I was like, dude, you're so Miss Mom started laughing. He's being mean, man. I don't know what his problem is. I was just trying my name with the pencil. He got mad. I was like, you need to calm down.
The only thing you might have trouble with is making sure you enter it in correctly.
build up stage.
The girls were gonna do like if they missed a workout, they were gonna do the workout they missed.
Yeah.
Or if we didn't miss one,
I don't know.
day off.
You're probably right, Strider. Who knows?
We did diagonal session.
I would bet
I don't know,
Four
because Coach
striders.
Walton does all the girls, so. The only time we talked to Coach Walton is at hurdles.
He didn't do hurdles.
No, hurdles like the stretching.
Oh.
hurdles,
Gotcha.
'cause we
Walk,
switch
hurdle walk over.
sides. That's the only time we talked. And in athletics, when I do hurdles there too, so.
Okay, what's the quote?
Thanks to
television.
Or I can't remember what he did, he said it's good.
Hold on, do something.
Okay, so what happened when you did 1 over x plus 2? Bart, what happened to the graph?
Shifted to the left.
Went left 2, didn't it?
Mhm.
Okay. How about this one, negative 1 over x minus 2?
It was in different
It moved
quadrants
right.
and went
It moved
down
down.
to.
Yeah, it moved down 2, that was the minus 2. And then the negative made it flip from here to here and from this down to up to here. Okay. So the negative in the top makes it do what? Flip over which axis?
X.
X-axis. The number on the outside does what?
Which
Vertical,
way it moves?
vertical shift.
Okay, up or down?
Yes.
And then the one underneath with the X moves it how? Left or right? Okay, so on that other paper that I gave you,
This
we're gonna summarize this, yes.
back and forth.
Back and forth, yes. Okay, we got A over X minus H plus K. What does the H do again? Moves it left or right. What does the K do? Up or down. And the A does several things. One thing, if it's negative, it does what?
Flips it.
Flips it, okay? And we're gonna look and see what happens as it gets larger or smaller, okay? So I'm gonna go back to here, y'all don't need to go back to here, but I'm gonna show you, okay? This one, the thanks is for 2 divided by x. Okay, notice there's a point at 2, 1 and a point at 1, 2, okay? And then on the one where 4 divided by x, that's this one down here. What happened to it? How does this one down here compare to that one?
It's a
Vertical
point
stretch.
above.
Yeah, it's like stretched away from
It's closer.
the
to being-
origin. Yeah, this one is closer to the origin. Okay? And look at this number right here. 4, 1 and 1, 4. Okay, because that can tell you how much it's stretched by. This one's stretched by 4. This one's stretched by 2. But it doesn't stretch at all, it's going to go through 1, 1. Okay? If it gets closer in here, that's a compression. It'll be like a half. Okay? All right, so on this paper, this is a vertical compression, stretch, or reflection. That's what A does. It either compresses it, stretches it, or reflects it. Okay, it stretches when A is a larger number or greater than 1. When A is greater than 1. Okay, so it pulls it, stretches it away from the origin. It compresses it when A is between 0 and 1. So we're going to put 0 is less than A is less than 1. Like a half or a third or something like that. And the A is on the top, so you might have like a third up here, like this. And that stretches it, or that compresses it. Okay, and it reflects it when A is less than 0 or negative. And it flips it up over the x-axis. Okay, this is a horizontal what? Shift. Or translation.
That looks really cool.
Moves right.
Like shift.
That moves right when H, okay, moves right when it's negative, moves left when positive. Always does the opposite on left and right.
It looks kind of like the tangent.
Yeah, it does a little, except tangent goes all the way down. But it has
Yeah.
tangent, cotangent, they both have asymptotes, and cosecant, and secant. They all have asymptotes, just like this does. Okay, then vertical shift moves up when
Positive.
and moves down when negative. Okay, we're gonna write the equations for these down here. So we're gonna look and see how it moved. How did this first one move?
To the right 3.
The right three,
So
so,
negative x minus 3.
okay, but you'd have 1,
over
X minus
minus
3.
3.
good. And minus 3 is down here with the x, moving it right. Okay. Then this one, how did it move?
Up 1.
Up 1. So how do you
One.
show that?
1 over X.
Plus
or
1.
Yeah, plus
Okay.
1 out.
Plus 1 on the outside,
Yes.
not down there with the x.
In the calculator.
You would have to put parentheses around that, that's right. Okay, and you could here too. Right, and then on the last one it moved
Up
up to,
2, right, left 1, so
okay,
X
x
plus
plus 1.
On the inside.
Okay,
X minus
1 over,
1 over x minus 1.
actually x
One
Oh,
over
x
plus
plus
1, because if you do the opposite, right, since
Plus
it went
2.
left, we do plus.
And then
Plus 2
plus
on the
2.
outside.
Plus 2 on the outside.